Oil's value comes, of course, not only from its usefulness, but also from its scarcity. While large amounts of oil exist in some countries, such as the United States, Saudi Arabia, and the Soviet Union, other major industrialized nations, including many in the Far East, must import virtually every drop they use. Another myth helping to paint oil as a sort of international bonanza is the perception that oil simply comes bubbling out of the ground and into the hands of those fortunate enough to find it. In reality, oil is hard to find and often very expensive and difficult to produce. No better example exists of the lengths to which man must go to find and produce oil than a project called Endicott. It is a technically difficult and financially risky venture being undertaken in Alaska's icebound Beaufort Sea, 250 miles above the Arctic Circle. In the mid-1960s, long-term U.S. access to foreign petroleum supplies was as uncertain as it is today, prompting American oil companies to accelerate their constant search for new domestic reserves. The most significant strike of the era came in 1968, with the discovery of an underground reservoir holding an estimated 20 billion barrels of oil. The reservoir, the largest in North America, was located at Prudhoe Bay on the remote north slope of Alaska. The development of the Prudhoe Bay field and the construction of the Trans-Alaska Pipeline were the most ambitious and most expensive tasks ever undertaken by private industry. The rewards, however, were plentiful. An average of 1.5 million barrels per day of oil has flowed out of Alaska. That's over 20% of current U.S. oil production and approximately 10% of U.S. consumption. Significant factors when considering America's balance of payments and foreign oil dependence. But even reserves as large as the one at Prudhoe Bay don't last forever. And geologists have conducted extensive exploration throughout the Arctic to find other oil fields. One of the major operators of North Slope oil fields has been Standard Alaska Production Company, part of BP America. Standard Alaska's Mike Curtis.
We're really interested in the Arctic because the area contains large geologic structures that contain oil. And there is a large potential also for many more to be discovered. Serious exploration began just after World War II in the mid-40s. That was by the federal government and in the National Petroleum Reserve area. Commercial exploration began in the late 50s and the early 60s. The area is more explored than parts of South America, Asia, and Africa, but less explored than certainly the Gulf Coast and other parts of the lower 48.
Some exploration efforts have succeeded. Others have failed. An estimated $750 million was spent on one offshore Arctic project known as Mukluk. But what came up from the test well at Mukluk was mostly water, not petroleum. Another site which has fulfilled its promise is the Endicott Field, located 10 miles northeast of Prudhoe Bay in the Beaufort Sea. The Endicott Reservoir is estimated to contain about 1 billion barrels of oil, of which only about 1/3 are thought to be recoverable. Although far smaller than the Prudhoe Bay field, it is still the 9th largest oil field in the nation. Consequently, a consortium of major oil companies and Alaskan native corporations decided to develop Endicott. Standard Alaska led the project. Standard Alaska's president, George Nelson.
The major financial challenges at Endicott were the initial capital investment to develop the project. The original estimates were on the order of $3 billion, and right away we knew that wasn't going to fly, and that we couldn't go ahead and develop the project at that type of a cost estimate. So a lot of innovative work was done by both the engineering and operations people to bring those costs down, which they did. And The project was then approved at about $1.9 billion, and the go-ahead was given, and we proceeded with the project. During the process of going ahead and doing the project, a lot of additional things were done to lower those costs, and when we finally ended up, it was just a shade over $1 billion.
Going after the oil at Endicott would be a test then not only of the oil industry's technological skills, but also of its ability to turn a hard-to-tap petroleum reservoir into a profitable venture. The technical problems alone were immense. The Endicott Field is more than 2.5 miles off the Alaskan coast, while offshore drilling operations take place everywhere from the Gulf of Mexico to Europe's North Sea. Endicott would be the first permanent production facility in Arctic waters. That meant it would face a confrontation with a powerful, relentless foe, ice. For all but a few months a year, the Arctic Ocean is a vast, seemingly endless expanse of ice. Dangerous and unpredictable, the ice is divided by scientists into two classifications: pack ice and landfast ice. Pack ice is composed of great ice floes that endlessly circle the North Pole at a rate of about 15 miles per day. Landfast ice encrusts the coastline for all but a few months each year. In between these two forms of ice, sea lanes open and close, sometimes almost overnight. Slabs of ice override each other, crushing and shearing off huge chunks called pressure ridges that are at times 150 feet thick. Pressure ridges have been known to ride up and over anything in their paths. Archaeological evidence indicates that entire Eskimo villages have simply been wiped out by these giant walls of ice. Beyond designing for the crush of ice was the problem of working in the Arctic environment. Under normal conditions, most oil production facilities are located outdoors, but the Arctic is anything but normal. Winds and almost total darkness reign for nearly 6 months of the year. More devastating is the cold. With the wind chill factor, temperatures of from 80 to 100 degrees below zero are commonplace, temperatures at which human flesh can actually freeze within a matter of seconds. To meet these technical challenges, Standard Alaska chose to develop its production facilities not on offshore platforms, but rather on two man-made islands. The islands and the 5 miles of causeway linking them to the mainland were actually made of gravel. Geologists located a nearby quarry site on the mainland. Work crews cut away 1 million cubic yards of ice and soil to reach the gravel below. 70 massive earth hauling units were brought in, some driven to the North Slope in the dead of winter from as far away as Seattle. The trucks were filled with gravel and then driven to the water's edge where they deposited their loads. Bulldozers distributed the material, while the earth haulers returned to the quarry for more gravel. Construction began in March of 1985 and continued day and night for 9 months as the islands and the causeway grew up inch by inch from the bottom of the Beaufort Sea. By the time the project was completed, 7 million cubic yards of gravel had been dug out of the quarry and used to build the haul road, the 5 miles of causeway, and the islands. One island was 45 acres in size, the other 10 acres. Together, they were the largest man-made oil and gas production islands ever constructed. Exploratory islands had been built before in the Beaufort, but none had been made to last more than a few years. The Endicott Islands must last 25 years, or as long as it takes to bring up all the recoverable oil. That means they must be protected from the erosion that could be caused by both waves and ice. To protect the islands from wave action, they were lined with thousands of gravel-filled bags. But the bags alone could not be counted on to fend off the crush of ice, which can exert pressures of up to 1,300 pounds per square inch. The solution was to make thousands of 4-foot square concrete blocks and link them together by chain to form a sort of armor plating around the most vulnerable portions of the islands. Building islands and miles of causeway in previously open water was more than an engineering challenge. Since the beginning of work on the North Slope in the mid-1970s, environmental protection has been a high priority. Standard Alaska's Pam Pope talked about environmental concerns on the Endicott project and the strict government regulations the oil companies had to satisfy.
The Endicott development project took approximately 3 years to permit, involved 25 major permits and numerous secondary permits that had over 100 stipulations and conditions attached to them. The major concern with the Endicott development was the construction of a causeway extending out from the landfall. There was concerns that the causeway itself would act as a physical barrier to fish movement. To handle the fish movement and habitat concerns, 2 breaches were stipulated to be placed within the causeway structure, a 200-foot and a 500-foot breach. To evaluate fish movement and distribution along the coast here, what we've done is we use a passive sampling technique, or a fike net, to collect fish. These nets are checked daily, and the catch is evaluated for length, weight, and species. And to date, they have not shown any definite conclusions that the causeway is changing this habitat.
Constructing the islands was only a part of the job. Building the oil and gas production facilities themselves was an entirely different task. Construction work on Alaska's North Slope is inherently costly and difficult because of the remote location and the harsh climate. Consequently, most production facilities have been built in the lower 48 states and then shipped by barge to Prudhoe Bay. The process, called modularization, is akin to building a major factory, cutting it up into sections, shipping each section to Alaska, and then reassembling the entire facility, rather like putting together a giant jigsaw puzzle. Design of the Endicott facilities was carried out at the Ralph M. Parsons Company of Pasadena, California. Parsons, a worldwide engineering firm, had designed a majority of the oil and gas production facilities on the North Slope. Charlie Botita, project manager for Parsons.
The engineering phase actually started, the detail engineering phase and procurement started in end of June 1984, and it essentially extended to about mid-86, and that's the bulk of it. We peaked at about 420 people on the project. That includes engineering, procurement, all the support services, and construction supervision. We've got a total of 6 major modules on this project. One went up with the 86 sea lift, and that was about 2,000 tons. We've got 5 major modules going up with the 87 sea lift. The largest of that is the gas compression module, which is 5,000 tons without the transporter beam. If you add the transporter beam, it's 5,400 tons. And the dimension of that structure is like a 10-story apartment building. It's 95 feet wide at the base, by about 185 feet long, by 110 feet high.
The Endicott modules would be labyrinths of mechanical and electrical equipment and piping, most of it enclosed by walls to afford workers protection against the Arctic cold. Modern engineering allows for the interweaving of these elements, but when millions or even billions of dollars are at stake, the designers need to be able to check for any possible mistake or flaw in the system before the facilities are built. So in addition to all of the plans, blueprints, and drawings, exacting scale models were produced to ensure that every single element of the production plant would fit in place. Building the real thing was another story. Before Endicott, most of the oil and gas facilities on Alaska's North Slope had been fabricated at construction sites on the Pacific coast, places like Stockton and Alameda, California, Portland and Astoria, Oregon. and more than anywhere else at Tacoma, Washington. But Endicott was perhaps the most tightly budgeted North Slope project ever undertaken. That meant finding the skilled labor needed to build these behemoth modules at the best possible price. New Iberia, Louisiana seemed as unlikely a spot as could be imagined for such a job, primarily because it's a long way from the North Slope of Alaska. But New Iberia, located 150 miles from New Orleans in the heart of Cajun country, was in fact a town which had a long and profitable association with the oil industry. Offshore rigs and other petroleum-related facilities have been built alongside its bayous for years. That meant that a plentiful supply of experienced, skilled labor was available there. Electricians, carpenters, welders, iron workers, and skilled craftsmen of almost every description flocked to New Iberia for a chance to work on the Endicott assignment. Also pouring into New Iberia were hundreds of tons of structural steel, thousands of miles of pipe, valves, electrical equipment, and other components of the facilities. The assignment for the hundreds of workers at New Iberia was to fashion these elements into operating equipment to raise oil from the depths of the Beaufort Sea. Despite the size and bulk of the material, the job was far more complex and far more delicate than it appeared. First, massive concrete slabs were poured to serve as foundations. Then the largest pieces of equipment, giant oil separation and pumping units, were installed. Next, the steel superstructure was erected and covered with metal siding or walls. Once they were in place, workmen installed smaller pipes, electrical components, control systems, heating systems, and ventilation equipment. The construction phase of the project took more than 2 years, providing a major boost to the economy of the area. New Iberia Parish President Craig Romero.
In Iberia Parish, this Endicott project has meant in the neighborhood of 1,500 jobs, possibly even more than that, and in terms of payroll dollars, close to $20 million over the last 3.5 years, which is very, very important to our well-being over the last 3 years, because at present we're close to a 20% unemployment mark, and still this job has contributed tremendously to the economic well-being of our area.
6 major and dozens of smaller Endicott modules were fabricated in New Iberia. They were shipped to Alaska in 2 sea lifts. The first in the spring of 1986. The second 1 year later in May of 1987. The task of transporting these gargantuan structures was almost as complex as building them in the first place. Giant crawlers, much like those NASA uses to move rockets, were slipped under each module to lift it off the ground. Then, proceeding inch by inch, the crawlers carried each module to a dock, where it was loaded on a massive barge for shipment to Alaska. Pulled and pushed by tugs, the barges slipped off down a meandering Louisiana bayou, drawing the attention of onlookers and even a few surprised glances from boaters who'd never before seen anything quite like the modules. It took the barges nearly a full day to reach the Gulf of Mexico. A little over a week later, the barges, pulled by 9,000 horsepower ocean-going tugs, began an historic leg of their 10,000-mile journey, entering the Panama Canal. Approximately 50 miles long, from deep water in the Atlantic to deep water in the Pacific, the Panama Canal is one of the true wonders of the world. Its famed locks raise or lower ships a total of 85 feet to allow them to go from ocean to ocean. But not all vessels can pass through the canal. The locks themselves are 110 feet wide, and so the barges, which measured 108 feet wide, slipped through with only inches to spare on each side. The journey from the Atlantic entrance at Colon to the Pacific exit at Panama City took a full day, during which each barge glided silently along the Placid River, crossed the Gatun Lake, and finally reached the Freedom Bridge at Balboa. From Panama, the barges headed north on a 70-day journey toward their final destination in the Arctic. Outside Seattle, Washington, the barges rendezvoused with other equipment being sent to Alaska. From there, the fleet passed through the Aleutian Islands and headed for Point Barrow, the northernmost site in the United States. The timing of this last leg of the journey is critical. So critical, in fact, that the entire construction and transport program is geared around it. That's because Arctic ice normally blocks the sea lanes near Point Barrow, opening up for only a brief 4 to 6 week period each year. But nature is always unpredictable. In 1975, the year of the first North Slope sea lift, this window through the Arctic ice failed to open for the first time in the 20th century, stranding many of the barges offshore for the entire winter. 1986 proved to be one of the better years. The single Endicott barge sent that year carried a module that contained electric generators, a water desalinization system, and other vital life support systems for the production islands. It reached Endicott easily. But the 1987 sea lift, involving 4 Endicott-bound barges, encountered far more difficulty in rounding Point Barrow. Ice, wind, and especially fog blanketed the path from Wainwright to Point Barrow for days. Finally, an icebreaker was brought in to create a path for the Endicott flotilla. The vessel, a huge barge with a reinforced bow and 2 tugs providing power, plowed its way through the ice, with the fleet following close behind. The fleet reached Endicott Island in mid-August, anchoring offshore. The barges were then brought to a dock and offloaded. Giant crawlers carried each module to foundations cast into the man-made island. The process of setting the 4,000 to 5,000 ton modules on these foundations is a painstaking one, with each operation consuming hours. Once in place, the modules were hooked up to one another, providing the final connections on the oil and gas production equipment. But even before their arrival at Endicott, another link in the chain that brings oil to market was already being forged. To bring oil up from beneath the Beaufort Sea, 100 wells were planned, most reaching a depth of nearly 13,000 feet. To drill the wells, 2 specially designed drilling rigs were built, rigs capable of being driven from well site to well site. The massive cantilevered rigs, riding on some of the largest tires ever made a slow and painstaking march across the 2 production islands. Working in both summer and winter, crews brought in nearly 250 miles of well casing, and one after another cemented 40-foot lengths of the casing into the earth to line each of the wells. The Endicott Reservoir covers 14 square miles, yet all of the wells had to be drilled from the 2 gravel islands. That meant the operators not only needed to drill their wells close together, but also drill them at some of the sharpest angles ever used. Several wells were actually drilled almost horizontally, 2 miles beneath the surface of the earth. The final link in the chain was the Sales Oil Pipeline. It was built completely above ground to allow wildlife to move freely and to make maintenance activities easier. The pipeline reaches the 3 miles from the main production island to the shoreline, then stretches another 24 miles to the west to link up with the first pump station in the Trans-Alaska Pipeline. By early October of 1987, all of these facilities were in place. Last-minute testing had been completed, and Endicott went into operation, almost a decade from the date when the reserve was first identified as a site where oil could be produced. Over the course of that 10-year time span, Standard Alaska and its partners had completed a project that would be considered staggering by any standards. They had employed more than 400 engineers and technicians to design their production facilities, hired some 1,600 skilled craftsmen and laborers to build them in New Iberia, and used more than 600 people to put them in place in the Beaufort Sea. They had erected 2 man-made islands in one of the most remote spots on Earth, working in an environment so hostile that only the bravest venture into it. And taking into consideration the cost of the Alaska pipeline extension needed to reach Endicott, they had spent more than $1 billion. Ironically, most of it at a point when oil was selling for its lowest price in years. Endicott is now pumping oil at a rate of more than 100,000 barrels per day. When the natural gas that is re-injected into the wells is no longer sufficient to keep up wellhead pressure, water will be injected into the reservoir to keep the Endicott Field in operation. Oil is a major factor in the economy, not just of Alaska and Louisiana, but also of many other states. In fact, materials or services from 41 states were used in the Endicott project. But oil is of special importance to Alaska. Alaskan Governor Steve Cooper took part in the Endicott dedication ceremonies.
We've had about 20 years now of the oil industry in Alaska, and I think that it's probably correct to say that the feeling is practically unanimous among all Alaska citizens that this industry has helped each and every person here in Alaska. Anybody who lived here 20 years ago can tell you that housing conditions were not anywhere close to what they are today, that the kinds of public services that are now available in Alaska were nowhere near what they are today, and that the makeup of the population here in Alaska has become more professional, more able to compete in the worldwide economy, and that practically every aspect of the oil industry of Alaska has touched us in a positive way.
Native Alaskans have also profited from the oil and gas business. Arctic Slope Regional Corporation President Jake Adams.
The Endicott project brought jobs for our shareholders. They worked in the pipeline and also the installation of the modules, and it's been very good for our people since jobs are becoming scarce on the North Slope.
All business ventures carry risks, and despite the myths, the oil business is no exception. While the profits generated from oil sales can be significant, the losses from unproductive or ill-timed ventures can be staggering as well. Endicott is one example of a risky venture that will probably pay off for Standard Alaska and its partners. But the payoff comes only after years of work, technological breakthroughs, and fierce human determination to overcome the obstacles thrown up by nature in the cold, bleak world above the Arctic Circle.